So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a question on elasticity, basically on the calculations of stress and strain. So here we are being given a fixed cube and a force F is applied at an angle of 36 degree with respect to the upper surface, which is EFGH face. Then first question is we need to calculate longitudinal stress on the face EFGH. So we just take the component of forces. Here it will be F cos theta, here it will be F sin theta. And for longitudinal force, we need to take perpendicular component of force, which is here F sin theta. And the area corresponding to this will be L into V. So the longitudinal stress will be F sin theta upon BL. Sin theta is 3 by 5. So we have 3F by 5 BL as the longitudinal stress on the face EFGH. That is answer to the first question. Second is shear stress on face EFGHs. So for shear stress, we need to take the parallel component of force, which is along the surface. So here force along the surface is F cos theta. So cos 37 is 4 by 5. So we have 4 by 5 F by BL as the shear stress on the face EFGH. Then in another question we need to find the ratio. So from here you can calculate the ratio as it will be equal to sin 37 by cos 37. Substituting the value we have 3 by 4. Now there is another question, then find longitudinal stress if F is 200 Newton, L is 2 meter, B is 4 meter. So just substitute the value 3 by 5 F by LB, and after calculations we have 15 Newton per meter square. Then we need to find shear stress. So shear stress in the previous question was 4 by 5 F by BL. Solving this we get 20 Newton per meter square. Then again we need to find ratio of longitudinal and shear stress. So taking the ratio, we have ratio as 3 by 4. Next question is dimension of stress, M and 1, L minus 1, T minus 2. Similar is the dimension for shear stress. Then the ratio, so since dimension is same for both, the ratio has the dimension M0, L0, T0. Then we have another question based on prism. Here a force is applied as shown in the figure. We need to find longitudinal stress on the face ABCD. So you just take the perpendicular component of force which will be F sin theta over here. So it will be F sin theta by area. Area can be calculated as this is a rectangle, so the area will be, this side can be calculated as root L square plus B square using Pythagoras theorem. And this length here is given to be L. As this is L, so this will also be L symmetrically. So this will be the longitudinal stress on the face ABCD. Next is shear stress on face ABCD. So take the parallel component of force, which is F cos theta by A. So that will be the shear stress. Next, find ratio of longitudinal and shear stress. So that will be tan theta. So in this way you can see that we have used the basic terms, the basic concept, the basic vocabulary related to the topic. So make sure that the purpose of these videos is to check your basic understanding of the topics. So if you have done the topics, then go through these videos. It will just take about 5 minutes and you will be analyzed through different basic vocabulary, basic concepts, basic terms. And if you are able to complete the entire DPP within 5 minutes, so that means you are very good at fundamental level. All the best for your exams. If you have any doubt, you can ask in the doubt section. Thank you and have a nice day.